let's reduce some fractions, okay? So let's start with a random story. Let me get this great big yellow bowl right here, and I'm gonna trace it on the board. Here we go. So here's what's going on right now. Tracing this so I can have a perfectly round, I hope it's gonna turn out nice. Nope, it's a mess, oh well. So told you it'd be messy. So we have this perfectly round pie. My wife makes pizza. And so she's like, hey, I made you a pizza, Adam, let's have dinner. And I'm like, yes, thank you, wonderful. And there's this one random dot that's a scratch on the board, so ignore that. It's a crumb, fell off the pizza. And then she takes out the pizza cutter and she cuts it this way. She cuts it this way. She cuts it this way. And she cuts it this way. And I eat more than her, it's just a thing. So she's like, how many slices would you like? And I'm like, I'm starving. And so I decide I want these 4 slices right here. So I have taken, now as I write this, you're like, oh my gosh, I've seen this. Okay, I'm starting with the most basic fundamental concept and we're gonna make this thing go really big, really fast. So I have taken 4 out of 8 slices. Clearly I took half of the pizza, right? So like 4 out of 8 is 1/2, all right? So no one's arguing, it's half the pizza. Well, my wife goes, well, I'm not as hungry as you are. And so she says, I want this one, and I want this one. And so she takes 2 out of the 8 slices of the pizza, and I look at that and I'm like, clearly that is 1/4 of the pizza. And we have just reduced 2 fractions in the most basic way ever. Let's make this thing much, much harder. Okay, so like 4/8, 2/8, we're all good. We can reduce those. But what I'm gonna do is start with an easy example and I'm gonna make it seem complicated. Like I'm gonna do it in a way that might be a little bit wacky or difficult. But that level of difficulty is gonna be necessary when I have crazy numbers, which we will get to in a moment. So let's actually start with 12 over 20, and the directions on this will just be to reduce it. So basically you have pizza, you cut it into 20 slices, and you're gonna eat 12 of them. How much of the pizza do you eat? Well, I'll go ahead and tell you, you're gonna eat more than half of it because, well, half of it would be 10, you ate more than 10, right? So, okay, so totally unnecessary way of doing this that I'm about to show you, but it might be necessary for other problems that are harder. So, you might say 12 breaks up into 3 times 4, and that breaks up into 2 times 2. All those are prime. We've done this before. 20 breaks up into 4 times 5. 5's a prime. 4 is 2 times 2. Those are prime. So here's where this is going. Any factor that I have on the top, that's also on the bottom, I can cancel them out. They divide out. So 12 is really 3 times 2 times 2. Okay, so 3 times 2 times 2. I would use exponents. I choose not to. All right, 20 is really 2 times 2 times 5. So 2 times 2 times 5. If I see something in the numerator that's also in the denominator, then I grab a red marker and I mark them out. And whatever I'm left with is my reduced answer, right? So, oh, I see a 2 here, I see a 2 here, they're gone. I see a 2 here, I see a 2 here, they're gone. And we are left with 3/5. Now, I hear you. Some of y'all might be like, I knew that, I saw that, I got it. I hear you, that's fine. I did one this way because when we get to crazier numbers, things will be just a little bit, well, crazier. A lot of you probably noticed that the number that goes into 12 and 20 would be 4, and you did this, and you canceled out the 4s, and you still got 3/5. It works, it's fine. This is where I'm hoping we'll all be in our head eventually, but this is the process that I think will get us there. Just that, gaining that number sense. So let's just go ahead and do one that's a little bit more difficult. Let's do 98, not one that people think of often, divided by 168. So 98 divided by 168, and we're gonna go from there. So same idea, let's do it the same way we just did the last one. Maybe you can start dividing things out. You probably, if you're like me, you're noticing they're both even, so we can divide a 2 out. I hear you. I'm not gonna do that, but you could. So here goes. I'm gonna come down here and do what we just did. So 98 is 2 times 49. 49 is 7 times 7. We're good. All right, we're done. Everything's prime. So 168. I know it's even, so we'll divide 2 into that. And that gives me 84. 84 is even. We'll divide 2 into that. That's prime. That's prime. That's 42. That's even. So we split that up into 2 times 21. And we split that up into 3 times 7. Okay. So we have factored it, and we'll cancel some things out. So 2 times 7 times 7, the numerator, that's 98. The denominator is 22237. So 2 times 2 times 2 times 3 times 7. And we're going to cancel. So let's get the red pen and let's start canceling. So if you see a pair, cancel them out. But it has to be top and bottom. See, there's a pair. Here's a pair, but they're side by side. You can't do that. Here's what's really happening. 2 goes into 2 one time. And so what I really am doing here is saying I have 1 times 7 times 7. Well, when you multiply by 1, it doesn't change anything, right? So we have that. So 7 cancels with this one down here. And if you want to get technical, 1 times 7, and there's a 1 here. So in the numerator, we have, I'm taking an extra step here that's totally unnecessary. We have 7. In the denominator, we have 2 times 2 times 3. 7 in the numerator, 4 times 3, so 12. 7/12. That one's not obvious. That one's a little harder. Many of you would look at that and say, oh, let's divide by 2. I hear you, you're right, but what about the 7? So we can probably get the first part and then what, okay? So let's keep moving. Let's do another one that's a little wacky. Not as crazy as this one. Not that that one was super crazy. And let's divide 12 by 76. Okay, if you're like me, you might jump at this and say, oh, 4 goes into that and 4 goes into that. Go for it. Like, if you don't want to do all the factoring down here, that's fine. That is great. I'm going to actually shift gears. Let's not do this, and let's do this. I know this is 4 times 3. I know this is 4 times, oh, wait, I don't know. Divide 4 into it, and you get 19. If you didn't know 4 went into it, that's fine. You can do all the stuff down here. Now, I could go further and say, well, let's see, 2 times 2 is 4, and 2 times 2 is... No, let's just go ahead and cancel them. You're gone, you're gone. Now, 3 is prime, and 19 is prime, so we're done, actually. So it's really just 3 over 19. That one was pretty straightforward. So let's do 3 more. I'm going to write them down, and then we'll tackle them one at a time. If you're trying this and you're just having so much fun that you can't stop, then I recommend that you, well, do them, pause the video, just have fun, because, you know, math is fun. Don't disagree with me. You know I'm right. All right. 25. Is it 25? I'm looking at my notes. Ooh, that's a good one. 25 over 75. We'll do that one. Yeah, I'll just put it down here. Next one will be right here. It's going to be 26 over 169. I was trying to cover up that spot on the board. And then 9 over 13. Okay. Let's do them. Or pause it. Try it on your own if you want to. I wonder what goes into 25 that goes into 75. Now, you might have already thought of the biggest thing. The big idea is to divide out the greatest thing you can divide out. The greatest common factor. But if you don't know it, that's okay. Like, I may not look at this and think, oh, I know it goes into both of them, and I might just say, that's 5 times 5, and that's okay. And I might look at that and say, you know what, that's 5 times 15, and that's okay. You might say, that's 25 times 3. You're right. I'm going to not do it that way. I'm going to do it this way. More than one way to do it. There's more than one way to reduce a fraction. 5 over 15, are we done? Actually, we're not. See, this is the first one where I've gotten part of the way and was like, I'm done. Oh, wait, no, I'm not. So let's keep going. 15, I know what 15 is. I'm going to erase that. I'm going to call it what it really is. It's really 3 times 5, right? Okay, so I'm going to divide out those 5s. And 5 goes into itself one time. So I have 1 on the top and 3 on the bottom. So if you reduce and everything's gone, it's not 0, it's actually 1 that's remaining because of the way things divided out. Okay? So I'm going to shift gears a little bit here. For this one, I'm going to do the factor tree, just because. Variety, you know, variety is fun. 26 splits up, oh, it's even. 2 times 13. 13's prime. 169 is, oh, I don't know. Okay, a lot of people look at 169 and they're like, it's prime. It looks prime. A lot of things look prime, but they're not. 91 looks prime, but it's not. 101 looks prime. And it is. Okay, so 13 times 13, it's a perfect square. Fun little trivia fact. 13 times 13 is 169. Surprise your friends at parties. You're gonna get kicked out of a party if you walk in and you're like, hey, I know what 13 times 13 is. Okay, we see what's about to happen here and we have that. So it's 2 over 13, and that one's not a big surprise. We got it, 2 over 13, we're good. Okay, last one. I hope you're thinking what I'm thinking. I think so, brain. That's Pinky the Brain reference. Okay, so 9 over 13, and I want to know, let's see. Now, if I was to do my little factor tree, and I will, briefly. If I was to do that here, I'd have 3 and 3, and then I'd have 13, and it doesn't factor, it is prime. So I'm left with this thing where I have, this is kind of a waste of time, but I'm going to write it anyway. I have 3 times 3, and I have 13, and then nothing cancels. No, I can't cancel a 3 with that 3. That's just wrong. So I can't do anything, and so it's 9 over 13, and so it was already reduced. There was nothing else already reduced, not reduced as. There was nothing else left for me to do with it. So there we go. Several methods of doing it, and find the one that works best for you.